Hi class, this video is going to walk through doing a chi-square test in SPSS, and we're going to do it with a data set with 100 individuals and a data set with 200 individuals. Within each data set, you'll see that we have ethnicity coded as 1, 2, and 3, and then poverty coded as 1 and 0. When you look into the variable view, you can see that the 1, 2, and 3, 1 is for individuals who are white, 2 black, and 3 Chicano. In poverty, 0 indicates that an individual is below the poverty threshold. 1 indicates that an individual or their family, their household, is above the poverty threshold. On ethnicity, it's classified as nominal. We can't rank or order them. For poverty, we could rank them. Individuals who are below it are going to make less money per person in the house than individuals who are above it, so we can classify that as ordinal. Importantly, both of them are categorical in nature. Once the data is set up, we can go into Analyze, and the chi-square is actually under Descriptives. So if you go down to Crosstabs, to make it mirror the Excel document, I am setting ethnicity as my columns and poverty as my rows. This will allow you to more quickly, easily compare and contrast the two things. For statistics, we want the chi-square, and then we can also do Cramer's V. And this will allow us to have an effect size for the chi-square test so that we can look at 100 versus 200, and what we should see is that the chi-square test itself is impacted by the sample size. However, Cramer's V, the effect size, is not impacted by the sample size. On cells, we want observed and expected. Again, this will allow us to quickly and easily compare between our Excel documents to make sure that our calculations are consistent and to see where these numbers are coming from. And again, if SPSS uses different labels, this makes it pretty easy to go, oh, okay, that's what SPSS calls it, but this is what we've been calling it, or this is what the textbook calls it. So we're going to click continue. We're not going to do anything under format or style, but you can always look into those on your own. And then I'm just going to hit OK. If I look in the output, I see that I have 7 individuals who are below the poverty threshold that are white, and I have 60 individuals. So where it says count, that is my observed. And of course, if you wanted to make it changed to match, you could always change this to say observed. That way it would be consistent with the way that we referred to it. You could also put FOFE for frequency observed, frequency expected. And so these data are consistent. Importantly, and we've talked about this before, the way that the individuals get distributed across these groups for the expected values is saying, okay, if based on the number of individuals who are white, which is 67, we had basically 15%, and that only works because there's 100 people. But if we had a proportional number so that they were equally represented compared to these other groups, what would we expect to have happen? So our total expected and our total observed are always equal to each other, but the distribution, the way that they get distributed across these categories is a little bit different if there is an association. Now, if there's no association between these, then we would see that this number and this number would be relatively consistent with each other. There would be very little deviation between observed and expected. Because of that, our chi-square would tend to be low. So when we look, the total below for observed and expected both equal 15. The total above for observed and expected both equal 85. So we always have the same number of people in each category across all of our other possible categories. So we have the same number of individuals in this black category, but the distribution, the way that they get split between above and below, is a little different if there is an association compared to what is observed. So we see that that table matches with the table that we've created in Excel. Our Pearson chi-square, the obtained value is 3.657. Degrees of freedom is 2. And importantly, this is not significant. If we look at Kramer's V, we see that that is 0.191. Now we're going to run this with 200 individuals. And so here, this is the data set with the n equals 200. So it continues to go. Again, the way that I created that to make sure that the associations were the same in the n100, n200, I just copied and pasted the data. So we know we have the same effect size overall, but now we've doubled our sample size. When we go in and we run that chi-square under descriptives crosstabs, set up the same way. Columns are going to be ethnicity, rows are going to be poverty. We're requesting chi-square and Kramer's V for the effect size. On cells, we've again requested observed and expected, and we're going to hit OK. When we look in our output, we now see all these numbers are simply double what they were before. The percentages are identical between n equals 100 and n equals 200. So the percentages are identical, except now instead of 7 here, we have 14 because it's double. If you look back, this was a 4, now it's an 8. So again, all that's happened is those have been doubled. Our chi-square, similarly, is almost double. It is very much related to the sample size. So what this means is we can almost make any difference, and there's almost always some difference. We can almost make any association significant if we simply have a large enough sample size. So now, suddenly, we have a significant association between ethnicity and poverty. And if we look, though, Kramer's V, still identical to what it was before, still 0.191. That's one of the important aspects of effect sizes. We can, with this test, sometimes make it do almost what we want, and there are limitations to that, but you as an informed consumer should know, hey, chi-square test is really sensitive to sample size. You're doing this test with, 10,000 people, which if we're looking at national data or political data or medical data, sometimes they have really, really large sample sizes. They come out with this is significant, this is important, but you as an informed consumer go, hey, wait. Let's look at these effect sizes. Let's look at some confidence intervals because I know that particularly for chi-square, it is sensitive to sample size. And some of the other tests are also related to sample size. And we've talked about that before. If all things are equal and I increase sample size, I always have more power. Chi-square in particular is sensitive to sample size, but that is true for all tests. We want to be aware of that. We want to be informed consumers so that when we're reading a journal article or when we're reading something in the New York Times or the Post or some other outlet, we know to pause for a second, think critically about what they're telling us, maybe then go back to the original research, the study, the report that they're citing, because sometimes journalists, they're not always scientific journalists, and so they have limited information, they have limited experience themselves with these things. But two, sometimes they kind of inflate things, sensationalize things. We want to be aware that sometimes there's just an error. Sometimes people are misrepresenting their results, and maybe it's the authors kind of playing it up. If this is something that's important to you, it's a project that you've spent a year or two of your life on, you can imagine you want to show how important it is to other people. Well, we as informed consumers go, yes, is it important to know this? If there is an association between ethnicity and poverty, and there is that a societal thing that we want to address? Is it an issue that we want to try to alleviate? Yes. Do we want to have misinformation? Well, no, that actually gets in the way of addressing the issue. The more informed we are, the more accurate our information, the better able we are to then address the issue and see, okay, what are the ways that we can address this? What are the factors other than just ethnicity that are related to it? Is it about their parents' education? Is it about their parents' previous employment and then that maybe limits them or because they have student loan debts and things at higher rates, they struggle sometimes financially? What are the factors that then we can address and we can try to alleviate? And some of that may be systemic, but some of that may also be things that we could address more easily than having to completely revamp the whole system. And so we want to address this issue. The question of how do we address this issue, the more accurate our data, the better we can decide what is the linchpin that's going to see the biggest move. And then when we see that move, then we reevaluate our data and go, what's the next thing that I can do to address this societal issue? So that shows you, though, how to do a chi-square test in SPSS. It also gives an example of the importance of sample size for chi-square. And again, we've talked about that in relation to power for other tests, but this provides a very obvious example that we can make the chi-square almost double by doubling our sample size.